Hello again! Let's go ahead and compare and contrast the different types of chemical bonds and intermolecular forces. Atoms freely floating about in space are not considered molecules, elements, nor compounds. To be considered anything organized, such as a molecule, element, or compound, atoms must be bonded together via chemical bonds. So, what is a chemical bond? A chemical bond is just an attraction that holds atoms together. Emphasis on atoms, right? And so it looks something like this, where each of these purple lines represents a chemical bond holding the different atoms together within their respective molecule, element, or compound. Looking at our four main types of chemical bonds, well, first of all, starting basic, they are all chemical bonds. So they all have to do with an attraction that holds atoms together. Now, when you hear attraction, I want you to be thinking about magnets. Positive poles attract negative poles and vice versa. Atoms are not special. So thinking back to our protons and our electrons, these two also attract one another, right? Positive attracting negative, negative attracting positive. So we are going to be focusing mainly on electrons, as these contribute the most to forming our chemical bonds. So what separates polar covalent from nonpolar covalent, from ionic versus hydrogen bonds from one another? Well, each bond is variable in how strong they are, meaning how tightly they hold atoms together, and they're all based on electronegativity. They're based on the electronegativity of the atoms or elements they are bonding together. So, what's electronegativity? Electronegativity is formally defined as a chemical property that describes an atom's ability to attract electrons towards itself. But what does this exactly mean? To answer this, let's revisit our friend atom. Now, orbiting atoms are electrons, right? Which I've colored in red. Well, when two atoms become very close to one another, they begin to associate with each other, and their electrons basically become shared between the two atoms. Now, when this happens, which atom do you think will hold onto those electrons more tightly? Well, in this example, we see that the one that quote-unquote wins this electron sharing battle is the light blue atom. Because of this, we would call the light blue atom more electronegative than the dark blue atom. But why is this? Why is our light blue friend able to hold onto those shared electrons more tightly? And why is the light blue atom considered more electronegative? Well, it largely has to do with protons. Protons are positively charged. Therefore, just like a magnet, they attract more electrons, which are negatively charged. So it stands to reason that the more protons you have, the more electronegative you are, because you are able to attract more electrons towards yourself. Make sense? And we can see this to a degree in the periodic table too. Lucky for us, the periodic table is laid out by the number of protons each element has, right? Those numbers at the top of each square. And therefore, it is also basically organized by how electronegative they are. The low or weakly electronegative elements are found on the left-hand side of the table, such as hydrogen, lithium, and calcium. And the high or strongly electronegative elements are found on the right-hand side of the table, such as fluorine, chlorine, or iodine. So if sodium were to associate with chlorine to compete for their electrons, chlorine would attract the electrons more strongly to itself than sodium would. And therefore, we would call chlorine more electronegative. Also, as a side note, electronegativity also increases slightly as you move up the periodic table too. Here's a lovely cheat sheet with elemental electronegativity values that I suggest you either take a screenshot of or copy down in your notes. I do think this will help you moving forward. And like every rule in life, there are some notable exceptions. Here, those notable exceptions are our noble gases, which you find in the right-hand column of our periodic table. These guys are notably not electronegative at all, so just keeping that in mind as we move forward. Now, let's apply what we just learned about electronegativity with how it relates to our nonpolar covalent bonds, our polar covalent bonds, our ionic bonds, and our hydrogen bonds.
Keeping in mind that the top three bonds that are on the screen are chemical bonds, while hydrogen bonds are actually something a little bit different, but we'll touch on that later.